But all good mathematicians will try to look for multiple ways to solve one problem. Here's another way we can solve this problem. F of x, when we divide the top and bottom by, we can try to divide the denominator into the numerator. We'll get a quotient of 3, but we're still going to have some left over because it won't divide evenly. Now we can split cases and talk about it. X can be equal to 1. If x is equal to 1, then f of x is just equal to 3. But if x is not equal to 1, so the numerator is not 0, what will happen? In order to be able to use what we know about rational functions, we need to get the numerator to be a constant. So in order to do that, let's divide the fraction by x minus 1 on the top and bottom. So we're left with x squared minus x plus 1 over x minus 1 in the denominator. And we can rewrite the denominator as x plus 1 over x minus 1. Now it's starting to look familiar. We need the denominator part and this front part to have the same shape. So they need to be identical. What we can do is have x minus 1 plus 1 over x minus 1 to make x minus 1 repeat 2 times, but then in the end, just add on a 1. So now we need to split into further cases. What happens when x is greater than 1? We know that x cannot equal 1 itself because the denominator of a fraction cannot be 0. But when x is greater than 1, the denominator will have to be greater or equal to 3. So then f of x's value would fall in between 8/3 and positive 3. The other scenario is when x is less than 1. In this case, the denominator will be less than or equal to negative 1. So f of x would fall between 3 and positive 4. So in this case, we both see that 3 is not inclusive in the possible values for f of x. But earlier on, we said in a certain scenario, f of x can indeed equal 3. So in the end, when we combine what we learned from the two cases, we know that the range of f of x must go from 8/3 to 4 inclusive.